Deep beneath the ocean's surface exists a world where sunlight has never reached. In this eternal darkness, life survives in ways that challenge everything we understand about nature. These deep ocean creatures are not monsters. They are survivors, shaped by crushing pressure, freezing temperatures, and millions of years of evolution. The deep ocean begins beyond the reach of sunlight, where silence dominates and survival follows entirely different rules. Water pressure here is powerful enough to crush metal, yet fragile-looking creatures endure against unimaginable odds. Food is extremely scarce in the deep sea. To survive, creatures must conserve energy, move slowly, and strike only when the moment is perfect. One of the most famous examples is the anglerfish, often seen in viral deep ocean videos. In total darkness, it uses a glowing lure to hunt silently. The light appears inviting, almost hopeful, but it is a deadly trap. When prey drifts close, the attack happens in an instant. Because meals are rare, anglerfish can survive long periods without eating. Even deeper lives the giant squid, once believed to be a myth. This real creature evolved enormous eyes to detect faint shadows in the darkness. Giant squids hunt large prey and sometimes engage in violent encounters with deep-diving sperm whales. Scientists believe their lives are short but intense, often lasting less than 5 years. In the deep ocean, patience matters more than speed. Bioluminescence becomes a silent language, used to communicate, hunt, and avoid predators. In endless darkness, light itself becomes the key to survival.
Near underwater volcanoes, life survives without sunlight, relying instead on heat and powerful chemicals rising from the ocean floor. In these extreme zones, deep-sea ecosystems follow rules completely different from the surface world. Giant tube worms thrive near hydrothermal vents, growing rapidly despite having no mouths or digestive systems. Inside their bodies live symbiotic bacteria that convert toxic chemicals into usable energy. This process, known as chemosynthesis, replaces traditional feeding and sunlight-driven photosynthesis entirely. In food-poor depths, survival often depends on rare opportunities. The gulper eel, frequently seen in viral deep-sea footage, has a massive, expandable mouth that allows it to swallow prey larger than itself. This unusual advantage helps it survive where meals are unpredictable. By moving slowly, gulper eels conserve precious energy while patiently waiting for their next chance to feed. Many deep ocean animals appear alien to human eyes, but evolution here follows survival, not beauty. The barrel-eye fish, for example, has a transparent head that allows it to look directly upward. Its tubular eyes rotate to capture the faintest traces of light, maximizing vision in near-total darkness. In places where vision fails, some predators rely on vibrations and sound to locate prey. Permanent darkness pushes creatures to develop highly efficient and creative hunting strategies. Some deep-sea species live for decades, while others survive only a few intense years. In extreme depths, survival is a constant balance between growth, movement, and energy use.
In the deep ocean, temperatures remain near freezing, forcing life to adapt at the most fundamental cellular levels. Cold water slows metabolism, allowing deep-sea creatures to survive longer on extremely limited food supplies. One remarkable survivor is the vampire squid. Living in low oxygen zones where most animals cannot survive, it drifts slowly through the darkness, conserving every bit of energy. Unlike other squids, the vampire squid does not actively hunt. Instead, it feeds on drifting organic particles known as marine snow. This slow and efficient lifestyle allows it to survive long periods with very little nutrition. In total darkness, some deep-sea fish no longer rely on sight at all. Over time, eyes become useless and disappear. Instead, These fish develop highly sensitive lateral lines that detect vibrations in the water. Even without vision, they can sense approaching predators or prey with remarkable precision. Many deep-sea crabs survive as scavengers, feeding on remains that sink from surface ecosystems. Among the most important events in the deep ocean are whale falls. When a whale dies and sinks to the seafloor, its massive body can support entire ecosystems for decades. These rare food explosions attract specialized scavengers, and some species have evolved to depend almost entirely on whale fall environments. In the deep ocean, survival often means waiting patiently for rare opportunities. Many species reproduce slowly, investing energy into fewer but stronger offspring. Larvae may drift for years, spreading life across vast distances. Every strategy reflects millions of years of adaptation to extreme conditions.
In the deep ocean, many predators rely on patience rather than speed. Ambush hunters remain completely motionless, waiting for the perfect moment when success is almost certain. One powerful example is the fangtooth fish. Despite its small size, it carries oversized teeth designed to trap prey in total darkness. The teeth remain exposed even when the mouth is closed, ensuring that once prey is captured, escape is nearly impossible. Even aggressive-looking predators move slowly, conserving energy in an environment where every calorie matters. Another master hunter is the dragonfish. It produces a unique red bioluminescent light, one that most deep-sea animals cannot see. This invisible illumination allows the dragonfish to spot prey without revealing its own position, turning darkness into a powerful advantage. Life strategies in the deep ocean vary widely. Some species grow slowly and live for decades, while others grow quickly and reproduce early, trading long life for survival through numbers. Because meals are unpredictable, many predators consume anything they encounter. Expandable stomachs allow them to store food and survive long periods without feeding. Survival also depends on remaining unseen. Transparency helps some creatures avoid detection, while others rely on stillness. In this silent world, even small movements can attract danger. As depth increases, familiar rules of life disappear. In the deep ocean, survival depends on perfect timing, efficiency, and instincts shaped by extreme conditions. Humans often understand distant planets better than the deepest parts of our own oceans. Even today, more than 90% of the deep ocean remains unexplored, hiding countless unknown species and ecosystems. With every advanced expedition, scientists continue to discover new forms of life. Many of these organisms survive under extreme pressure, freezing temperatures, and in complete darkness. Some live without sunlight, warmth, or oxygen levels that humans depend on. Their existence challenges our understanding of biology, survival, and evolution. Life in the deep ocean proves that nature can adapt far beyond human imagination. Each creature plays a role in a fragile ecosystem built on balance and limited resources. Disrupting these deep environments could have consequences that reach far beyond the ocean, potentially affecting Earth's climate and surface life. The deep sea remains Earth's last great frontier, a vast and silent world filled with mystery. These hidden survivors remind us how small we truly are within the natural world. Exploration is driven by curiosity. The more we learn about the deep ocean, the better we can understand and protect it. Countless stories still remain undiscovered, waiting beyond darkness and pressure. If the mysteries of the deep ocean inspire you, your journey of curiosity has already begun. Subscribe and like to continue exploring Earth's hidden worlds through powerful documentaries. This is Infinity Documentary, where every story goes deeper than the surface.